second type of electrolytic cells are, electrochemical cells are electrolytic cells. An electrolytic cell is a cell that requires an input of electricity, some sort of a power source, to cause a non-spontaneous redox reaction to occur. So if you have a more reactive element, but you want to force it to be reduced instead of oxidized, you can do this in this type of a cell. This does require a power source. We use these for things like electroplating. So if you have a metal, for example, white gold is actually yellow gold with rhodium plated over it. So it's actually just regular gold that's covered in another metal. This is very common also as a way of taking kind of cheaper jewelry and maybe plating it in something like silver so it has a different appearance. Okay, there we go. You make what you want to plate the cathode when you're doing electroplating, and it will be reduced. So you're actually taking ions and turning them into a solid metal. These cells are not spontaneous. They have to be driven by a power source. If we were plating this fork with the silver in here, what we'd actually be doing is turning this silver into silver ions, which would then go get reduced on the surface of the fork, thus coating it in silver. So another example of this is a little bit a better diagram. If we want to, for example, plate this ring with silver, we would put a silver anode in. The silver anode is oxidized and turns into these silver ions. Those silver ions are going to then travel over to our cathode. At that cathode, they are going to gain electrons and be turned into elemental silver, which then coats that ring. So ions are going to continue to be reduced on the surface of that ring, and you're going to have more and more thickness the longer you let the cell run and how much current you flow through the cell. Another example, this is actually what if you need, for example, solid sodium, which does not occur in nature. So you're taking a highly reactive metal and trying to turn it into a solid that is not combined, is not in an ionic form, is not in a compound form, but in regular element form. You can do so by using an electrolytic cell as well. So in this cell, what we're actually doing is we put liquid salt or a molten solution of sodium chloride into the cell. Our cathode is just a little piece of material that will allow these sodium ions to attract over to it, where they can gain electrons and turn into sodium atoms. In order for this to occur, the electrons are actually being released from the oxidation of chlorine, which is causing little chlorine bubbles in the circuit. These are another couple of examples of electrolytic cells. What you will notice is they have a power supply of some kind on them. This is actually the symbol for a voltmeter. I'm not really a huge fan of this particular diagram, but this should really be a power source right here. So you're going to notice these are in one container. You don't have the two containers in the salt bridge, and you have something that is drawing current instead of you using current. In both cases, however, you do have the same direction of electron flow. Electrons are flowing from anode to cathode, because the anode is always where oxidation occurs, and the cathode is always where reduction occurs. So you're going anode to cathode as far as your direction of electron flow in both of these cells. A nice comparison for these, just to go through some of the main ideas you're responsible for. Voltaic cells are making electricity or making current through spontaneous reactions. The major parts, we got the salt bridge, the two electrolytes, our cathode, our anode, and our voltmeter. In an electrolytic cell, you still have the cathode and anode. This, you're going to have one electrolyte solution, and this time you're going to have a power source. The difference in energy, when we talk about a voltaic cell, we're taking chemical energy to spontaneously create electrical energy, whereas in an electrolytic cell, electrical energy is put in to produce a chemical change, a chemical energy, if you will. Anode and cathode are the same in each cell. Anode is always oxidation, cathode is always reduction. Voltaic cells are what we use as batteries, and electrolytic cells are used for things like processing metal, electroplating, metallurgy, that sort of stuff. So this can have a lot of uses if you want to make something out of a lightweight metal, but that lightweight metal might not be that resistant to corrosion. So maybe you could put a more resistant metal on the outside of it. In both cells, electrons are always flowing from anode to cathode. The major difference between these is the difference in whether or not they're spontaneous or not. So a voltaic cell is spontaneous. Reactivity and differences in chemical potential drive it to take that spontaneous chemical reaction and make current off of it. Another thing you're sometimes asked about are charges. In a voltaic cell, an anode has a negative charge and the cathode has a positive charge. In your electrolytic cell, this is actually the opposite. They don't ask a ton about this in detail very often, but it is fair game, so it is an important thing to know. I know it's a little bit confusing because it is backwards.